3 right there. Number 3, everybody. Let's take number 3. What I like you to do with number 3 then is take number 3 and let's solve it out. Let's think back to what we did last week. We did not just, last week did not just do one-step equations. This is what we call a two-step equation. Let's take number 3 here and let's attempt to solve it out. I'm going to put a quick minute on my clock, and I want you to take number 3 right there and try to solve that out on your own. We'll come back around and talk about it, but you got to try that out a little bit on your own right there. So there's a minute. Start off there on your own. Think back to what we did last week. What are we going to move first? There's the variable. What are we going to move first? The 2 or the 9? The order does tend to kind of matter. All right? Show me what you're going to do first. Give it a minute. Try on your own. And then we'll come back around and talk about it. Sorry, Krista, just chill, please. I'll give you another minute there. Try on your own. Okay. 2 to the 9. Where do you move first? You gotta try that on your own. Pencil and paper. Please shoot 3. So what's the inverse of minus? Okay, let's come back around. Let's talk about that first one there. So as I was walking around just a second ago, I did see at least a little bit better start off than I saw. Yeah, than I saw, I think on Friday it was. So that's nice to see. That's what we're looking for. You guys starting it off a little bit on your own. Curtis, I saw on your paper the right step to start off with, so it was good to see. Curtis, what's the first thing you did there?
Minus 9 on both sides.
You didn't have a minus 9. You had a
Plus 9.
You had a plus 9 there, bud. Yep. So we always move that addition and subtraction first. That's got to be our first move there is a plus 9. And that for that, those 9s are going to cancel. That's what we want to see. And then drop down that 2x. That's when we want to use that calculator. Everybody's got a calculator. 6 plus 9 gives us a 15. Now, here's where some of us are forgetting. What is in between that 2 and that x? What operation is always hiding in between there? Multiplication, right. When I say 2x, that is read as 2 times. So I always like to put in that multiplication symbol there. I always, if I'm helping you out, I always identify that multiplication there. And then inverse of multiplication, I keep using that word inverse. Inverse of multiplication is division. Show me that division to both sides. Now, last week, some of you were kind of being lazy. You just did that. Remember, show me, whatever you do to one side, keep it balanced, right? So, don't be lazy. And then when you do that, there's my x now appearing by itself. That's what we want to see. Now, we know 15 divided by 2 is not going to give me a whole number or an integer. It's, 7.5. That is a nice terminating answer. If you gave me that answer, I'd be completely happy with that, 7.5. But I also like fractions to be the answer. So 15 over 2, 7.5 or 15 over 2, either answer is appropriate. Okay, that's where we want to be. All right, let's roll with the next one. Number 4. Number 4 is a little bit of a trickier one. Now, we have not started talking about number 4 quite yet. That was not what we did on Friday or last week. Let's do it today now. This is, again, a prior knowledge skill with us. Okay, on number 4, let's do this, guys. What's the first thing that might jump out to that's a little bit different than, say, the previous ones?
Because there's 2 on the...
Yeah, there's 2 x's, one on the left, one on the right, one on both sides, right? We got to get those together. We got to get them on the same side. So it's like adding like terms. But in order to add like terms, we say we got to be on the same side, though. But they're on different sides, aren't they? So you're definitely on the right idea. We got to get them to the same side. So let's move them around. Which x is smaller? 2x. So if I were to move that 2x and cross it over to the other side there, just like you've been doing when you said add 9, Curtis said add 9 a few minutes ago, you want to keep using those same inverse operations. That's why Jayla said a few minutes ago, do we draw that line down the middle? Yeah, when you said equal sign, do that. Because whenever you're about to cross that line, you do an inverse operation. So it's a 2x. What's the inverse of a positive 2? So that's my inverse operation. Okay? I want to combine somehow that 2x and that 3x. But in order to combine it, as Andrew said, I have to do an inverse operation there. And the reason why I'm doing that inverse operation is I'm about to cross the side, from the left side over to the right side. So combine those by doing an inverse operation of a minus 2x. Absolutely. Now what's going to happen here? What's going to happen to those x's on the left side?
One of them's going to get canceled out.
They're going to cancel out. 2x minus 2x cancels out. Correct. Right-hand side. Don't overthink. What's a 3x minus a 2x give you? 1x, right? 3x minus 2x is just a 1x. 3 minus 2 is just 1. And then after that, you said, I want those x's to be together. Okay? So we bring all the x's together now.
Yes.
All the x's are where? On the left side or the right side?
Right.
They're over there on the right side, aren't they? I got you. They're over there on the right. Cool. Once they're all on the right, we are right back to kind of what we started on that first one. What are you going to move next to get that x by itself? We want to get rid of that negative 1. And what's the inverse of a negative 1, Kristen? Thank you. We want to add 1 now. So do that, guys. Show me that plus 1 to both sides. The x is on the right. Move everything over to the left. So just like Curtis said, add 9 on that first one. We're going to add 1 to that second one. Show me a plus 1 to both sides as Krista suggested. But I couldn't do that until we brought those x's together. And those ones cancel. X is by itself. And 12 plus 1 is 13. And I'm done. Is there anything else in front of that X?
No.
There's no 2X. There's no negative 5X. It's just X. Our goal is to just get X by itself. We did that. X is 13. Jevin? Whenever he comes back. Okay? So X is 13. So we got a little bit more going on with that. We're going to have a little bit more today going on with this. We're going to ramp it up a little bit. So let's do that. Let's flip it. Let's flip it. So let's go to the next page. This page here was Sarah and Ethan, page 249. Let's take Sarah here. Sarah's got an equation here, okay? So let's take a look at Sarah's equation. Negative 3x plus 14 equals 18 minus 5x. Now, it's saying it wants to verify that both Sarah and Ethan are coming out to get both solutions that x equals 2. So they told us the answer is 2. Let's check to make sure we're getting x to be 2 here. Or did we do something wrong? Or did Sarah and Ethan do something wrong? So we're checking to see if we get a 2 out of that. So let's use the white space below. Let's take Sarah's equation and let's use the white space below here. Let's drag it on down, guys. And as, again, Jayla said a few minutes ago, let's put our line down the middle. Give you a second to draw that out. And I want us to use the skills that we just did on that warm-up, that last one, to help us solve this out. Okay? So, we got this going. Think about what we just did on that warm-up. So maybe flip it back to that warm-up page, 247. Look at number 4 that we just did. All right, look at what we just did. Just as I think Chris and Andy said a second ago, on that first warm-up we did, we had X's on both sides. We got to bring them together. So in order to bring them together, we gotta move them around. We gotta combine like terms somehow. So in order to bring those together, we gotta cross the line though. We gotta cross that equal sign. In order to cross that equal sign, we gotta do an inverse operation. Now, which one are you gonna move? The negative 3 or the negative 5? It doesn't matter. Here's the thing about that, it doesn't matter. Now, my suggestion always is move the smaller one. It's not wrong, it's not right.
Negative.
But I would always suggest moving the smaller one only because you guys know that the negatives tend to make more mistakes on. If you move the smaller x, it gets rid of the negatives for you and limits your mistakes. So which one's smaller up there? Negative 3 or negative 5?
Negative 5.
Negative 5. So I would remove the negative 5x, get it to the other side. So what is the inverse operation of negative 5x? Show me that plus 5x, guys. Pick up that pencil again. Show me that plus 5x to both sides. Line it up vertically on both sides. I'm not going to go up there until you show me that plus 5x on both sides. What's that plus 5x going to go underneath? Okay.
Is it going to the 18?
Is that a like term? Plus 5x? Where's that plus 5x go underneath on the other side? There you go. So Jayla asked a good question. As I just said, line up vertically. Where's that going to go underneath? She said it's going to go underneath the what?
The 5x.
The 5x, and it's going to go underneath the what?
3x.
Thank you. Because that has an x. I'm not going to line up the 18. Line it up vertically with a like term. Now, after that, you guys got calculators. This is where the dumb mistakes happen. What does negative 3 plus 5 give you?
Positive 2.
Positive 2, right. I'm going to see an 8. I'm going to see a negative 8. I'm going to see a 2. I'm going to see a negative 2. Hell, I might see a 15 at some point. Please don't do that. It's going to be a positive 2. Jayla?
So don't put 2 underneath the 14?
2x Drops right down vertically, right? Plus 14. I haven't done the 14 yet, have I?
So what do you add it?
Give me a second there, Jayla. Hold on there, Krista. Equals 18, right? Haven't touched the 18 yet. I'm only doing one step here. What's happening to those 5 x's?
They get crossed out.
They're canceling out because negative 5 and 5 cancel out. Now, look back at the very first warm-up that we did, number 3, I think it was. This is the exact same setup, isn't it? This is the same setup that we just did. This is what we call a 2-step problem.
I already got
Okay.
the question.
Go finish it off now for me.
This coming-
You want to get back to something that is familiar. 2-step problem should be our familiar thing. Finish that off. Now, I'm going to put a quick minute on my clock. You have not finished that off now. You go finish off. What is the next step you're going to do? And then what's the other next step you're going to do? Okay? There's a minute to go. Don't just sit there and stare. Go at it. So what do you think you're going to do?
I'm just gonna keep the fraction one. So we dropped these two down, right? So the fraction, multiply.
No, we're working on. I think. He did share. Yeah, you're welcome. You're just substituting that as.
I don't know. Oh, it's down.
Well, this season makes it like.
You always wanna have that.
All together. 20 years.
Okay.
20.
So this guy over here by himself. This is when you got 14. What's the Thomas do in front of that 14? So, that's math, right? We need to minus, right? So minus your 14. So minus your 14 down here. Yep, do 0 on both sides. Okay, so. Now. Those are gone. Exactly what we want. So what do we have left over here? That down. Okay. What do we have on this side? 18 minus 14. What does that give us?
Oh, I can do it.
Oh,
Sure. Calculator.
All right. Let's bring it back around here.
So, G2X equals
Saw some nice things there.
Still have to get X.
Couple of you are hesitant of starting that off. Go with it. We all have pencils. Okay. So start it off. Subtract that 14. All right. As we subtract that 14,
Oh, right.
the inverse of that plus sitting there is a minus. And then lastly, divide. Okay. X equals what? Okay. We verified. Sarah, I think, is correct on that one. Now on the next one, let's take Ethan off to the side. 2x equals 5 minus. Okay, next one, 1/2 x. Okay, so on the next one here, let's draw a line down the middle. Now, for whatever reason, because obviously it's fractions, we lose our freaking minds. Okay? Some of us do, some of us don't. All right? But we're going to start off the same idea. We have x's on both sides. You want to bring them together to one side, either on the left or on the right. Again, my suggestion always is to you, move the smaller x. That limits your negatives. So just like in the last one, we added a 5x. That was the smaller one. Krista, you said on this one, what are we going to do here?
What else, right? We're gonna add a half x.
That is the smallest one because it's a negative. I don't care if it's a half. It's a negative 1/2 x. So show me that to both sides. Show me you're going to add a 1/2 x on both sides of that equation. So just like we did on the last one, clearly, go and show me a plus 1/2 x to both sides. Just underneath of it, show me that inverse operation. Don't need to actually do it. Just show me that plus 1/2 x underneath as the next line. All right? Can you show me that inverse operation correctly? That's half your battle. Put that pencil and do it. Where does that 1/2 x go on both sides?
Is it too much like that?
Can be.
So 1/2 x here, 1/2 x here. These are going to cancel for us. Great. And then the 5 is going to drop down. Cool. And this is where our lives become interesting, I guess we can say. 2 plus 1/2. Matt?
2.5.
Correct. So here's the thing. We know our fraction skills are not necessarily stellar. Matt just said
Okay, that's good.
2.5. Andrew said 2.5. All those are correct. Okay? And I'm fine with that. Okay? But as these keep getting a little bit nastier, I like writing these as improper fractions. Right. So let's change that 2.5, Matt said. Let's change that 2.5, Andrew said. I like writing these as impropers. Get into that habit. Your calculators all do that for you. Hit math. Fraction. 5/2. The backup calculators all do it. Okay, when you took it to your calculator, you did 2 plus 1/2 on here. did it as well. Did 2.5. Again, the button right before the enter key. Hit the button before the enter key. It changed it to 5/2. Everybody's calculator does it. If you're not getting it, tell me. 5/2. Now, how the heck do we deal with 5/2x? That's my next issue with you. Let's do it. That's what we're here for. Okay, we dealt with this last week in bits and pieces. You've dealt with it over the last couple years in bits and pieces. You're dealing with division. You're dividing by 2. What's the inverse of division? We dealt with that last week. Let's undo division by multiplication. Let's show that. Let's multiply both sides by 2. We did it already. This is nothing new. We did a problem like this last week, I know. 2 divided by 2 is gone. There's my 5x. And 5 times 2 is 10. Okay? Biggest, scariest thing on here was you had a half x. Cool, we added it with our calculators. You all have calculators, use them. And then 5 times x. The inverse of multiplication is division. And what is 10 divided by 5? It is 2. Thank you. We still get x is 2. Now, is that the only way to do that? No. There's more than one way to go about doing that. Okay? Excuse me. What's that?
Isn't it like a
Nope, there's one solution there. But there's just more than one way sometimes we'll solve these. But you only get one solution, too. All right. Now, with that, let's continue on here. Let's take the next one, number 2a. Let's do some more practice here on 2a. What's the first thing that jumps out to us? We already did it. Do it. How are we getting rid of these parentheses, people? It's up at the top there. What? Okay. You got something like that, Michaela? What is it? Distributive properties of Michaela. Do it. We did distributive properties. So, every time we do something a little bit new here, a different type of equation, it's going to take us back to something we've already done, something that should be familiar to us. Okay? It may not be 100% familiar to you, but we're going to get something back to, we've already done this. The more times we keep doing it, ideally it should kind of be, again, a little bit more familiar. So do that distribution property. Distribute that 3. All right. What is that? What's that going to give you for a new line, somebody? 6x plus what? 3, yeah. You're multiplying 6x plus 3. And what's going to be on the other side? It just drops on down. We didn't touch it yet. All right. And now we're back to something that we've already done. Something that is very familiar. We've done at least twice already here today. And I know you've done it in years past. Okay. We got to get these x's together. Look back at previous examples we've done. We've got x's on both sides. Which x are you going to move? Get those x's together. You got to cross that line, so we have to do an inverse operation. Look back at the previous examples. Jalen says 4x. I agree with you on that. So how are you going to move that 4x to the other side? You're going to subtract it. It's a positive 4x, and the inverse of a positive is a negative. So do that for me. Show me that minus 4x right there. And on that new line, I get 2x. And line it up vertically. Don't get lazy. As I heard, what is it? 2x plus 3 equals 6. Again, sorry, lost track. So then from there, we're right back to what we call a two-step equation. on that two-step equation, we've done it now multiple times here. Each time should be getting a little bit quicker. Jalen, give us a second. Okay, what's going to be my next move here then to solve this out? Subtracting 3. Subtract that 3 for us. Finish it off. Subtract that 3. Divide by that 2. Okay. Subtract that 3. Divide by that 2. Six minus 3. And then divide by that 2. Whoops, divide by 2. And as I heard from Andrew there, yeah, 3 divided by 2 is a nice terminating decimal. 1.5 is fine. I like fractions.
1.5.
1 and 1.5 is fine, or 3 over 2. I prefer impropers. 3 over 2, 1.5. I prefer 3 over 2s, which you'll see most of the time in your math classes. Okay? But every time you make, again, a new equation here, a new move, eventually that next move takes you back to probably something that's going to be we've already done. Now, on this one, we're going to come back around. We're going to do that justification that we've done in here before. They asked us to justify. So let's number this out. Let's number these steps here, the ones that I'm going to number here. 1, 2, the ones that I have in red. Okay. I have 5 steps that we did here with you. So we need to have 5 reasons that we just did. So I'm going to name this column as a statement column. And what's the other column that we called it? That's fine. That's what we're going over. A reason column. And I know some of us have nice handwriting. And I know some of us start to kind of go at a bit of an angle. So that's fine. All right, so let's number those steps like I did there. All right. Anybody remember what that first reason always is? I'm going to give you an equation to solve. In geometry, that's going to switch up on that. We're not in geometry. So I'm going to give Curtis an equation to solve. He may not like it, but I'm still going to give him an equation to solve. All right, Curtis, I gave you an equation to solve. That's called the given. Now, Michaela, what was the first properties that we used? Distributive property. Very good, Michaela. Michaela said we saw parentheses. If you see parentheses, more than likely that's the first thing we're going to do. That's the distributive property. So say it and do it. Okay? As we're reasoning this out, given our steps to go from one to the next, okay? Okay, as we work it through there, you're trying to then tell me what are the inverse operations that we did there. All right, looking at how we went from step 2 to step 3. What did we do to go from 6x plus 3 to 2x plus 3? Yeah, we went from everything stayed the same besides 6x and 4x is gone, and it made it 2x. And the only way to do that is the subtraction property. So we call that the subtraction property of equality. It's a mouthful there. You can shorten it down to say POE at some point, but I'm going to write it all out each time. Subtraction property of equality. Okay? POE. We went from 2x plus 3 to just a 2x. That 3 went away. How did that 3 go away to the other side? It's a plus. How do you get rid of a plus? What's the inverse of a plus? Subtract. We did the subtraction property all over again. You can reuse those properties more than once. Usually you don't use the distributive property more than once. Subtraction we can though. And then, because we subtracted 3 right here.
Oh,
Then we subtracted 3 right here.
no.
It's 2 subtraction properties. Subtracted 4x. And then we subtracted 3 to get right here. And now, to go from 4 to 5, we went from 2x to just x. Our 2 went away. How did our 2 go away? Now say it, Andrew. Now division. We had to do 2 subtraction properties to get to the division. Okay. I hear you. All right. We're going to do one more here, and we'll call it a day. Now, while this one more will come into play at, we're going to skip it down the road, though. All right, let's do one more here. And where I want you to turn is to page, we're going to use another example in our book here. We got a nice example, page 257, everybody. 257. 257. Let's look at that 1A. 1A right there. Let's finish strong on this last one. 1A. We're not going to justify, we probably won't have the time, but 1A. 257. Let's do 1A. Now we've done 1A quite a bit. One similar to that. I'm going to put 2 minutes on my clock here. 2 minutes this time. 2-minute warning. I'd like you to try that again on your own. Try 1A right there on your own. Look back to those examples that we've done. We've done a few examples already like that. We've had variables on both sides. Okay?
Remember what you said, is that good or homework? Okay. On 257?
Try that right there, just that 1A. What are you moving first?
There's actually 4 different ways to either X's together or just either regular numbers. So what do you want to move first? Try to get your X's for your numbers. You want your X's. Okay. So if you're subtracting your X from here,
Okay, here's the thing. If you want to do that, that's fine. It's already in my decision to start off with. It's the inverse of the negative.
Oh, right, plus 8, I forgot that here. Okay, that's also right.
so what is -7 minus 3?
Here's what's left over. Calculator 18 plus 8.
Minus 3.
Now we're
Where did you add?
It's attached to those numbers?
Sides, it's one get together, balance. So we have to put seven. Yeah, it's just like plus seven. Plus seven.
Now, over here.
Yep, you're fine. And then what's the after plus seven?
Are you okay, Frank? Very good. How do you?
Yeah, but
Look at it. It's not.
Multiplication, I think it's best because it's the inverse. Multiplication, but.
Oh, so oh, okay. Oh,
All right, ADHD.
I used to think that's.
I'm sorry, I
You're
got
fine.
two.
It's a fraction.
That was like when I was like.
Oh,
Well, I'm trying to think. Where's the chubby?
Yeah, I stopped taking mine when I was like 12.
X equals.
No more than 11.
Are you okay, Frank?
No, just